Our science correspondent Richard Westcott is there for us now. Richard.
Well, this is the Rising Path. It's the new feature at the Botanic Garden. It's open to the public on Saturday. Now, the idea is that you walk up the Rising Path, and as you go along, it teaches you some science. It teaches you about the evolution of plants, and it also teaches you how they categorise them. Because for thousands of years, they did it by sight, by how they looked, by what colour they were, by how the leaves were. And now they do it by DNA. Now they extract the DNA from plants in a lab over there, and they showed me how they did it earlier. So Samuel, we're going to get DNA out of plants and flowers. What have we got here?
So we have flowers of a species called mirabilis. So we have the leaf here and the flower here.
You're putting in liquid nitrogen now. I'm going to step back for this.
Yes, so this is very, very cold.
So it's a sort of witch's potion, isn't it, at the moment?
Yes.
So that's really cold.
Yes, it's really cold.
And now you have to crunch it up.
Yes, I need to grind all the tissue just to keep or make a powder. Some soap here, just to destruct all the tissue and extract that DNA out.
The process of getting DNA out of a plant is similar to that of a human.
Yes, it's very similar, the process.
And the genome of plants can be really complex, can't it? It can be really big.
Yes, that's correct. The genomes of plants can be even bigger than the human genomes, yes. Okay, so I finished with the flower. Can you do the leaf now?
Yes. Get in as much as you can.
Yes.
You're having to rethink everything when you look at the DNA, rethink how you think plants evolve.
Yes, that's correct. So in the past, they were using morphology, so how plants were different or similar to each other, either by the flower or by how the plant looks like. But now we are using genetics. So Richard, now we are going to mix this.
Shake them up.
Yeah, shaking well. And we're going to use a centrifuge here just to separate tissues.
So that little red blob and that little green blob, that's the DNA?
That's the DNA.
Now, for the sharp-eyed scientists watching, yes, the DNA would normally be white, but we left a bit of colouring so it looked better on telly before you email me, okay? So when you're on the Rising Path, these are the beds you're looking at, and these are really important. They were planted in the 1840s when the gardens were opened, and they actually have one family per bed, one plant family per bed. Well, all of that is changing now, so why is there a guy here waiting for me with a rose?
I feel like I should go down on one knee.
Absolutely. You're the curator now. You know, the curator in 1840 did it a certain way.
Yep.
Why are you holding a rose next to a stinging nettle?
I'm holding a rose next to a stinging nettle because back when the first curator laid out these beds, it was thought that roses and nettles were in two families that were very distantly separated. They weren't related at all. And what DNA has shown is that they are in fact very closely related. And so if we were going to be planting the beds today, we'd probably have the nettle family right next to the rose family.
Yes, you can see, I mean, you know, if they were just doing it by looks 200 years ago, whatever, there's not a lot in common really, is
And what they used back then were the flowers often, and clearly when you look at the flower, the rose and the nettle, they're so different.
Now, there's also a reason why this is here as well, because these two things look quite different. But,
yep.
but why was this planted in this way in
okay, so the nettle family and the euphorb family are planted close together because in fact they share the character that it's probably easier to see on this flower here, where in fact they just have
the camera in tight, yeah.
If that's okay, they have a single circle of leaves around those reproductive units, and although the nettle flowers are very small, they have that same feature. And those early taxonomists thought that was extremely important, and so they lumped all of these things together.
Now this has given you a bit of a problem, isn't it? Because all of these beds were planted in a certain way,
right?
And you want to respect the history, but you also need to replant them because you're realising things are related that people didn't realise were related.
That's right, so it's a beautiful heritage landscape, and it captures that moment in history. But now, of course, we still use them for science and teaching. We need them to be up to date. And so we've had to do this sort of tightrope walk where we try and update them as much as possible, but yet give a nod to history.
Now, obviously, we're looking into the DNA of plants. When you find things are too related, what's the scientific bonus of that? What do you get from that?
Well, I think it allows us to understand how plants have evolved much better if we know how things are related to each other. It also might allow us to find particular chemicals that we didn't know were in a plant but are suggested to be there because they're part of a group that we know is important for important chemicals or drugs or that kind of thing. So it can be very informative in that regard.
So beautiful garden, but also lots of important science still going on here. The Rising Path, like I say, opens to the public on Saturday. People can come along, have a look and learn a bit of the science.
Oh, Richard, you've opened a whole can of worms here tonight. People now thinking they can give nettles to their loved ones instead of that beautiful rose. Bring it back with you, though. It's a beautiful rose. It is. Richard, thank you.